And welcome back. As we continue our programming journey, today we're going to take a little moment to talk about the difference between protected and package access. Now, we have discussed some access levels in the past, and we've seen some of these modifiers and how they can kind of play a role in how things can work in our program. There are specifically two classifications of instant variables methods that allow them to be accessed by name within a derived class. We, of course, already know what public does because that allows it to be public. But there are two other identifications that really kind of help us to get those different things and how we can place additional restrictions upon them, because obviously public lets it be everywhere. But the ones we want to look at today, of course, are protected access, which always gives access, and package access, which gives access if the derived class is in the same package as the base class. Now, so let's first start with protected access and actually take a good look at what this means and how it's different from, for example, public access. Well, if a method or instance variable is modified by the keyword protect and it's protected, if a method or instance variable is modified by protected, if you see the keyword protect, then obviously it can be accessed by, first off, inside of its own class definition, so it makes sense, it's inside the class, so therefore you can get to it. Inside any class derived from it, so for example, if we think about our employee and hourly employee, that means hourly employee could still access it. And in the definition of any class in the same package, even if the class is in the same package but not derived from it. So think about like our date class. Date class is not related to employee or hourly employee. It's used by employee, but it's not part of it, so it could still technically access that variable. However, the protected method or instance variable cannot be accessed by name in any other classes. All right, so once it goes outside of that package, for example, it would not be able to be accessed by it. Thus, an instance variable is marked as protected in the class parent and the class child if they're derived from the class parent, and then the instance variable can be accessed by name instead of any method definition inside of that class child. So another way to think about this, it might be a little confusing, but if you have a derived class, hey, and it's protected, good to go. And we'll see a little bit more about some of this as we kind of tear this apart a little bit more about what this protected actually does. Now, one thing to remember is that a class that's not in that same package as the parent class and is not derived from parent, so the child, then it's pretty much as if that protected instance variable is private. All right, this is different from when things are public. Public means I can use it anywhere across any class and any program that's within that set of files. If I start going protected, it's actually making a little bit more restrictive. And we haven't really dealt with creating separate packages, so this is something we haven't really come across up to this point, but is the first kind of restriction that we have put in place. Now, let's actually look at this with some example. How do we actually use a protected? Well, if we look back at our hourly employee that we derived from our employee class, let's just say we're required to use access or mutator methods to manipulate the inherited instance variables in the definition of hourly employee. So for example, public string toString, return get name, get hire date .toString. We've seen this all before, nothing really new. All right. If those private instance variables, let's say name and hire date, had been marked as protected instead of as private, then we could change the definition of our toString to be the following. So we could say instead of, you'll notice it says instead of get name or get hire date, it simply just says name or hire date, which of course are the names of the variables in our base class. So you notice here we can then call it by name. And of course it's still some restrictions, but here you'll notice that we can now access that. Now the protected modifier is a kind of a nice little keyword that gives us some power. All right, but it's considered pretty weak by most comparisons here. All right, because if we look at the private modifier, it really keeps that restriction in place to make those instance variables that belong to one class. And the reason why it's weak is because it allows direct access to any programmer who's willing to go through the bother defining a suitable derived class. So if I really want to, I can then, of course, use those variables in any manner I want, as long as it's a derived class. Now, many programming authorities discourage the use of the protected modifier. All right, so even though it exists, and you might come across it, it's probably not something you're going to use as much. Instead, we want to think about anytime we have an instance variable, it probably shouldn't be marked as protected. And because most of the time we have a private instance variable, it's going to be private. We're not going to call it a protected instance variable. Now, there are rare occasions where you want a method marked as protected versus a private method. So we could change a method to protected, which actually makes sense. All right, so let's say, for example, we want to have a access level that's somewhere between a public access and a private access. Then the access that we're going to describe on the next slide, actually, though, is a little bit more preferable alternative to that of protected. So again, protection is not something you're going to see that much, but instead we're going to see the following. But before we jump into that, I do want to give us one quick pitfall reminder about that restriction on protected access, in case if you do use protected access. So let's just say we have a class called D, and we're deriving it from our class B. Well, the instance variable n has protected access in class B, and the classes D and B are in different packages, so our class definitions are going to start as follows. Package 1, class B, protected int n, package 2, import 1.b, so we're importing, of course, this class. And class D is extending B, so it's a derived class for D. Well, when we look at this example, a class that has marked its own classes inherited variables and methods that are marked protected in the base class, but cannot directly access any instance variables or methods of an object of the base class or any other derived class of that base class. So it's important to kind of think about this because it can affect how we start using our code. Again, this is not something you're going to see as often because it's not necessarily a recommended access level, but if you do come across it, it's still something that you should be aware of. All right, now that protected access, as I mentioned, it has restrictions. There are better ways that we're going to look at here. So if we want to keep looking at that pitfall, it's a way for us to kind of think about where, if we do have protected access, what should we be looking out for? Well, if we look at for a legitimate method that's in that class D, public void demo, n equals 42, and of course it is inherited from B, remember it was a instance variable of that one, just protected. Well, we could also say this is also a legitimate method from our derived class D. Public void demo 2, D object is new D, object D.n equals 42, and again, is inherited from B. However, there is something that's not allowed. Public void demo 3, and you'll notice it says B object is new B, object.n equals 42. This is an error. All right, and the reason for that is because n is protected in our class B, because you notice we're trying to create a B object this time instead of a D object, okay? So this is something that is very important to note here because we're trying to operate within this derived class, and this is in a different sort of package here that when we're trying to move across things. Now, you keep hearing the term package, and so now we can finally get to that other method of things that are going to be a lot better, which is that of package access. This is something that's going to be much more restrictive than protected, and it's going to be a little bit more recommended in some situations. So let's just say, if, for example, though, and you've actually might have seen this if you haven't done it, but if we, let's say, don't put on public, private, or protected as a modifier before our instance variable, well, you might notice your class is still going to compile. So instead of saying public, string get name, and you just put a string get name, well, your program's still going to compile. Why is that? Why is your program still going to compile? Well, if you don't place any of the modifiers before an instance variable or a method definition, then that instance variable or the method can still be accessed outside the definition of any class in that package, but not outside of the package. Right, and this is what we call package access, or it's sometimes called default access, or even friendly access. These are, of course, are different names for the same thing. We're going to use the term package access because it's going to make sense here as we start looking at this. So package access is situations where, let's say, we have a package of classes that kind of act as one single unit. We might see this, for example, we look at our employee class. We can technically, let's say we have employee, salary employee, hour employee, all these different employee pieces could kind of act as their own class, so to speak, our own group of classes, because they are all very similar in theme and function. Now, the package access, as I mentioned, is much more restricted than that of protected. And then also, it gives us more control to the programmer who's defining those classes. Now, if you control the package directory or the package folder, then you can control who is allowed package access. So with our package access, and let me just really quickly give you a visual outlay here. We have a public class A, public class B, This, of course, is in a package called sum package. And you'll notice that we have two classes that are derived here. We have class C, which is extending, and D, which is extending. And of course, we have this other class E. Now, you'll notice it says a line from one class to another means the lower class is derived, so that's these right here. Now, access, of course, means we can access it directly by name. So we have, of course, public int v1, protected int v2, and int v3. So this and int 4. So these are the four different access levels. So we have public, protected, a package access, and private. And if we look at this class right here, all right, this is all, of course, within the same package here. So class B is not derived from A, but it can access the public, the protected, and the package access. But of course, it cannot access the private one because, again, that's marked as private. If we look at C, you'll see because it's in the same package here, you can access the public variable, protected, and the package, but not the private. And with this derived class, it is not in that package, all right? It's not in this blue kind of shape here. So here, it can access our public, it can access our protected, but it cannot access the package or the private because it's not part of this package here. And with this last one, this one is not part of the package and it is not derived. So the only thing that it can see is the public variable. And of course, this is a good way for us to kind of look at how public, private, and protected access works within class structure. And it allows us to tell who can directly access by name those variables that have the public, private, or protected, or even package access. And the same rules that, even though we're looking at variables here, will also apply to methods. Now, the last thing I want to kind of talk about is forgetting about the default package, because actually we have been working with the package, even though we haven't really talked about packages up to this point. When we're looking at package access, don't forget that by default, things are in the default package. You might have seen this when you're creating your Java projects in Eclipse. So all those classes that do not belong to some other classes belong to an unnamed package called the default package. So if a class in our current directory is not in any other package, well, it's in the default package. You have to have a package, and by default, if you don't name it, it's this no-name empty thing called the default package. Now, if an instance variable method has package access, then the instance variable method can be accessed by name in the definition of any other class in the default package. And just to show you hyper quick here of course is a package from my 1.1 folder. You see that it says source, and underneath it says default package. In fact, if I look at, for example, even at 1.2 here, because I did not name it, you'll see I also have a default package here. So package access is one of those things that is granted anything inside here. If I wanted to make another package, obviously I could come in here and just do a new package, and then I could create a new package in here, and then I'm just going to call this one delete, just so I know to delete it. And if I hit finish, you'll see I now have a new package here, and I'm just going to go ahead and create a quick class here. I'm not worried about him. And you'll see this class now exists within this package called delete. And that is all it takes to create another package. And of course, this would have all the package rules that would have applied that we've talked about. Anything that's public can be accessed appropriately. Things that are, private obviously have the most restriction. But this is a great way for us to kind of look at some of these higher level concepts here with restrictions.